So for question 3 of the CTL lab, in your lectures you will have seen the oven model example. You'll see it here. It's a Kripke transition system. So you have your atomic propositions, start, close, heat, and error, and your transitions which alter these atomic propositions. Now this model has been replicated in the oven model.flow graph file. You can see it here. Now you can notice that this is the start node up here at the top because it has start node written. When an atomic proposition is false, it's not included as an atomic proposition. So you see here start, close, and error are true, and heat is false. So for the atomic propositions you just include what is true. So that's all you have to do. But this is already created for you. You know, maybe for the drink machine 1 and 2 you'll have to create it yourself, but again they're small models, it shouldn't be too difficult. So what I want you to do is try out the formula seen in the lecture slides and experiment with our CTL formula to see what you can discover about the model. So you'll see at the bottom here, you will see little formulas on the left such as error, heat, and other formulas, and just see what you get in the model checker. Try out the ones from the lecture slides, and then I want you to try out your own. Basically I want you to use the model checking view and just mess around to see what you can get. Just try different variants and just get used to the syntax. What can you find out from the model? Instructions for the use of gear model checker can be found on the following page, and there's a wiki page link in your document. Note that the model checker is for CTL formula only and uses infix notation, so ensure your parentheses in the formula is correct. This requires getting used to, as traditionally we use prefix notation. Also note that the name of a state is not the same as the atomic proposition. And the initial node of a model must have the start node atomic proposition. So you notice here in question 2 we had the two machines and there were state 0, state 1, state 2, state 3. However, state 3, the state was named 3 but the atomic proposition was coffee. So they're just not always the same. And as you saw here, the start node always has the atomic proposition start node. And if you want to add in more, you put a comma and then you put start, whatever atomic propositions you wish. So at the bottom of your document you'll see the model checker gear instruction set. So we have the model view. So again you can add in your models. So you just create heat, you check it, and you just click add, and that will store down here. So it just keeps a library of all the things you have checked. This is your preferences, you don't have to worry about that. This tells you what the model checking view, what you can do with it. So read through that. Then there's a built-in model checker, and this is just the syntaxes which you've used. So we saw in the last example we used the box and then followed by coin. So this is just shows you all the things you can do with the constraints. And this is your CTL operators. So again, we've gone through these in the previous labs, and it shows you how you can use them in the model checker. So all I want you to do in question 3 is look at this model, try out the formulas in the lecture slide, and then try out your own formulas, mess around with the syntax, and see what you can discover from this model.